Hello everyone, welcome to CMST290, Introduction to Scientific Programming and Machine Learning. We're going to be jumping back into Python this week. We've got a couple learning activities focused on, of course, Python. But to start us off, we're going to be doing just a quick revisit of what we did last week with regard to variables. Just kind of a quick run through, won't take too much time on our labs. It will be all labs this week, no lectures. We'll just be focused on two labs on Python. But we'll get us going with just a quick review of syntax, comments, and variables. And then we'll jump into data types, numbers, and castings for this learning activity. And then we'll jump into strings and booleans in the second learning activity. So let's jump on over to our Canvas and get a feel for what's going on, where we're at. Let's pull the syllabus up and do a quick temp check. So we are currently going to be jumping into week 4 learning activity. So I'm going to scroll down here. We've wrapped up learning activity 7, scientific programming and machine learning, last week, which was our lecture to get us kind of grounded in what it is, kind of high level, right? Revisit it. We did kind of a quick basics of programming in JavaScript in weeks 1 and 2, just to kind of get the programmatic juices flowing. And then in weeks 3 and 4, we're kind of hitting it hard. We're getting into what is scientific programming. And then learning activity 8, which was we kind of wrapped that up last week, was kind of getting our feet wet with Python. And then going forward, of course, we'll be in the Python programming language. So we'll be doing syntax comments. We did syntax comments and variables, and we'll just do a quick run through of that. And then learning activity 9 here for data types, numbers, and castings. That will be this week. And then i.e. this lecture / lab, and then learning activity 10 for strings, booleans, and operators. And that'll just about wrap up this week. And then, of course, as we move into weeks 5 through 6, we'll get into some data structures. We'll talk a little bit about machine learning algorithms, and then we have 2 labs in week 6 for unsupervised and supervised learning. And then we're kind of getting into the tail end of the course. So with that, let's go ahead and I'll revisit the syllabus, of course, as we move through the lectures here. But on the modules, I'll have these, as you are aware, because you are viewing this, we're in learning activity 9. And then we'll have learning activity 10 here opened up here this week. Okay, so let's go ahead and jump over to Replit. We're going to open up a new Replit. So let's go ahead and create a new Python Replit. And we're going to call this one Learning Activity 09. And this is Python. And we'll do Python. And this is going to be data types, numbers and casting. So we'll create a REPL, and this is going to be a familiar learning environment. This is all going to be something that we're familiar with. I'm just doing a double check on make sure I'm still recording here. Okay, so this is good console on the right, our programming environment in the middle. As per the usual, our information file explorer on the left with our tools on the left as well. A little bit of info on our CPU RAM, and this is all stuff we've talked about before. So I'm not going to belabor the environment too much more, so let's go ahead and get started. So to start off, we're going to do a quick run through, just revisit just high level what we did last week. So remember we talked about variables, and we did a little bit of typing, data typing. We didn't get too much into the weeds. We kind of kept it high level. We talked about integers, and we talked about strings. So in this case, for this week, we're going to go and dive in more detail. So to revisit, let's start off with just basic comment in Python, which was basic line comment. And we use that and denote it with a hash sign. So this is a piece of code that doesn't run. So if we run this, nothing happens on the console. And then we're going to create 2 variables. We're going to create a x equals to 5, and then we're going to create a y equal to Mike. Okay. And just for consistency, I'm going to use double quotes. And then we're going to say that this is a integer variable, and then this is a string variable. And this is all. And then we're going to just do a quick print, a print of x, and then we'll do a print of y. And so what you're going to have is you're going to have 5 print out first on the console, and then you're going to have Mike print out next. So we're going to run this, and then the console will give us output on the right over here, looking just exactly like what we expected. So this is just a revisitation of last week. And remember, one last thing that we can do is we can print the type. We can use a type function, and then we can wrap the variable in that and then run to find out what type it is. So in this case, it's a class of integer. And then if we put y in and rerun it, then we'll get a class of string. So that gives us exactly what we're looking for. And then I'm going to put a comment here, use type function, whoops, to determine variable data type. And there we go. Perfect. Okay, so that pretty much takes care of our first lesson. I'm going to actually, and one other thing that we talked about is a string literal. And that's this concept of the triple tick, what we call a triple. I like to use triple ticks. They're easy. And then I'm going to denote this is revisit of refresher of lesson, refresher of last week's learning activities. Okay, that's good. We're good there. So now let's I'm gonna give myself a little bit more room to code with here. I'm gonna open this up. Yeah, perfect. Because we don't need a lot on the console. Just kind of leave that there. Okay. Now let's go ahead and I'm gonna copy this, and then we're gonna go down into this week's learning activities, and I'm gonna move this down. So here on line 9, we're gonna actually jump into data type. So that was just a quick refresher on syntax, comments, and variables. That's our Python refresher from last week. Let's jump into this week. Okay, so to give you an idea of how many different data types there are, they're high level. This is I'm gonna create a line comment here for data types. Python lesson on Python data types. Okay, and then this section will cover data types. All right. Okay. Section. There we go. Okay, so first up is what we have is a text type, and you're familiar with that. And so I'm going to actually call these out the way they are. So I'm going to call this text equal to this is text, and this is a text. Oops, that's JavaScript. Text type. And then this is a text type. And then I'm going to create a bunch of, just in the interest of making this flow a little quicker, I'm going to create a bunch of variables real quick. So I'm going to create an int type, and this is going to be called int equal to, just like we've done, 1. And then I'm going to create a float. Let's do an int equal, well, let's make it a bigger number, right? There we go. And then what we'll do is we're gonna do a float, and this is gonna, and typically just from a matter of convention, we wouldn't usually just call the variable float. I'm just doing that for illustrative purposes, and we would actually make it more explanatory. We'd say int underscore a, like this. We would say a, because typically you would probably have multiple integers like int underscore a, int underscore b. Or you might say int underscore 1. There's just different naming conventions you can use, or you can even make them more explanatory, like int for car, like an integer for car, mph, like you would do something like that. So that's something that just to be kind of cognizant of. All right, so for the integer, we did that, and this is int type. And then for float, what we're going to do is we'll do the same thing, 20.5. And then this is a float type. And then from there, we'll do a complex. Complexes are, they're not used as much. I'm just throwing these out here so that you're familiar with them. And then this is a complex type. And I would say not as used as much. So at least, we'll see about getting into that. Now, this is what's called the, and I think I need to be a little bit better here. This is, I think I need to start using string literals here to make this a little bit more explanatory. So this is what's called, I'm going to use this here. I'm going to call this text types, text type. And these are going to be numeric types. I think this will make life a little bit easier because there's groupings of data types. So these are called the numeric data types within Python. And then what we're going to do is we're going to create one for sequence types. And for sequence types, I'm going to keep this simple. We're going to do list. It's a list object. And we denote sequences with brackets and or parentheses. And they can be and curly braces too. And the easiest way to go through this is just I guess just show you in a function. There's actually a function in here too, but it's just easier to show you. So the first most common one is a list, and let's just do apple, banana, and cherry. There we go. And this is going to be a list type. And then we're going to do one for tuple. And this is kind of an interesting one. We'll copy this tuple equal to, and we'll copy this. There we go. Tuple. And tuples are, you pass in a parentheses. There's a distinction here. So there's this and this. And there are a lot of ramifications to the type of data structure. We're gonna cover this in more detail next week. I just want to give you the high level of just the different data types. There are reasons why you would use a list versus a tuple. And there's reasons why you would use a dictionary, which we're going to cover here in a minute, versus these as well. There's different data structures for different use cases, and I just want to make sure that you understand that while the data inside here looks exactly the same, the structure itself and how the data is saved is different. So from that perspective, just know that these exist. We'll dive into the detail. There'll be plenty more time for that. Just know that high level, this is all you need to worry about. Okay, next up is a range. And I think that'll cover our sequence types. Range, and then range uses a function. And then we'll do range 6. And then this is a range type. And then and I'm actually going to do a print on all of these types here in just a minute so you can get a feel for all of these. But I think what we'll do is a mapping type next. So let me copy this down. And because they're similar in structure, a dictionary is called a mapping type. And there's only one in Python, so technically it's kind of like the list. I'm sorry, the text type. There's only a text type. There's only one. Numeric, there's multiple. Sequence, there's multiple. But mapping, there's only one. And this is a dictionary. And then the way you define dictionaries is with it's a more complicated data type. You can actually add fields to it. So for example, I will, I'm going to keep it that way just for now. So dictionary, what we'll do is we'll create, let's create a red, like color red. And then what we'll do is apple, and then we'll do let's keep it simple. Let's just say red, and then yellow, like this. And that should cover it. Now, dictionaries use what's called a curly brace. Yeah. And you have to make sure that both sides, like anything else, both sides are using a curly brace. There we go. Yeah, that takes care of it. And then this is a mapping type. There we go. And that looks good. And the difference between a dictionary versus a regular list structure or a tuple is these are indexed based on, they have an index that is an integer. I'm going to call this a integer based index, that how we access these, there's a positional access through an index that's not seen here, but you get it through memory. And I, again, won't go into the details, but we'll show what that looks like down the road. Mapping types, you can actually, they're coded by the field. They're to not get into the technical term, but dictionaries can be, so if I want to access the Apple record, I can, or field rather, I use the field name. So it's a named index versus a integer index. That's kind of the big difference. Like sequence types, you access via the integer index, and then on mapping dictionary types, they're named indexes. So that's we'll leave it there for now. Just know that that's how you access them. And again, there's different ways and reasons why you do that. Of course, dictionaries are more complicated, and they have more moving parts that you have to kind of contend with. And that's why we're here learning this. Okay. Next up, I think I'm gonna, I think for the purposes of what we're doing here, I really only want to show a couple more. I want to show a set and a Boolean. I don't want to go too much further because there's actually a lot more. If you want to learn more about the other structures, the Python data structures, you can take our, you can actually look up online. There's plenty of places that will show you where to go. Just type in Python data types, and you'll see a list of all the different data types as they relate to variables. In this case, you have frozen sets, you have Booleans, bytes arrays, memory views, and then there's actually a none type. But I want to stick to the high level stuff that's going to get most usage. So there's only two more that I want to show you, which is the set and a Boolean. So a set is, let's go here, and a set is has actually two. There's oops, I should do this. Come down here. Set types. And for this one, we're going to create a set equal to, and then I'm going to use the banana fruit thingy here that we've got going on. Copy this down and delete that. This is a set, and sets are, they use a curly brace just like dictionaries, but they don't instantiate a field See this colon here? That denotes that red is associated with Apple, as red is the field for Apple. And I'll show you what these all look like as we, and I'll get to the print function here in just a minute, and we'll, illustrate what everything looks like. Okay, so this is a set. This is a set type, and then that's pretty much all of your main data structures. There's also what's called a frozen set, and I'm going to put a comment. Also check out frozen set on internet. Okay. I'm going to say check out /research frozen set. That there's a frozen set within those, but we're not going to use those for our class. We're going to stick to this high level kind of. We'll probably only use about half of these in the course, just because it's a 1 credit hour course. Again, it's an introduction to scientific programming. We can't cover everything. This is just kind of covering the high level. Okay, and then last up for types, and trust me, we could go a little bit further, is we're going to go into Boolean. And there's only a Boolean type, one Boolean type. And I'm going to call this bool. And this is denoted by true or false. I'm going to set this to true right now. This is Boolean type. There aren't any other. Just, it's the only one. True or false? That's it. Okay, so there you go. That's all your major types. Now let's do a print on these, and we'll just kind of run through these real quick. We did that. We did this. Let's come up here. We're going to do a print text, and then we'll do a print int, and then we'll do a print list, and then we'll do a print dictionary. Yep. Oops. And then we'll do a print on set, and then we'll do a print on Boolean. Okay. So we're passing in, remember, we're passing this variable Boolean into bool, we'll decon set into set, and so on and so forth. So let's run these. Let's see if we get ourselves in any trouble. And that all printed perfectly. So this was the first part of our review, right? 5 mic class string. This is our text, 20. And then we have our data structure right here. That's our list. Then we actually have a dictionary output here, which worked just fine. We have our set output, and then we have a Boolean output. So that all worked. What I would encourage everyone to do is to try out float. For example, do float, and then rerun this and see what you get. You should see a change in what happens. You should see, instead of 20, you should see 20.5 over here on the right hand side. So I'm going to let you run through that on your own time, because we have some other things we got to run through. I will also, remember, you can type. You can do a print and do a type to determine what specific type you've got over here and that you're working with, because you've seen what that looks like from a string perspective, like a text type. You've also seen what that looks like from an integer perspective. But you can also pipe in float, complex, list, tuple. You can type the rest of these to see what it's going to return on the right hand side. And that actually, the type function is a good way to confirm the type that you're working with didn't in fact take as the type that you're expecting it to be. So it's a good test. All right, I think that just about covers data types. Again, there's other data types to go check out. There's bytes, byte array, memory view, and then there's a none type, but we've covered all the big ones. Okay, now let's go dive into numbers in a little bit more detail. When it comes to numbers, we have int, float, and complex. And I just want to take a little bit more time to expand on each one of these because for scientific programming purposes, these are very helpful. So let's do a deeper dive into numbers, or what would be considered our numeric types, i.e., numeric types. All right. So, and then we'll do, let's just call these, let's make these a little bit more explanatory. So we're going to do int x, and then we're going to do int y, and then we'll do int z. That way we keep these independent of the variables that we created earlier, and we're not going to get into any issues. So this is going to be an integer, and then we're going to create a float, and then this is going to be a actually, you know what, I'm gonna change these to nums. num z equal to, and so we've got one, and then that's a little bit more specific to what it is that we're creating here. Types, not tupes, types. There we go. And then let's do 2.8, and this is a float. And then we did this earlier, 1j, and this is a complex. Okay, so then let's go ahead and print these out. And then, so that way we can see print num x, and then we'll run these here, and we're going to be looking on an output on the bottom, so that's 1. And then over here we're going to do num y. Rerun this, num y, and then that's going to be 2.8. But you're probably curious, like, what does this complex look like? Num z. Run that, and then what you're going to get is 1j, just like it looks. Okay, so nothing, no rocket science, nothing crazy going on here. So let's move on. So that's the numerics. That gets us started. Now what I'm going to do is we're going to dive into each one of these, like with the the integer, specifically the int data type and the range of it. So let's go into numeric int type. Okay, and then we're going to say num x equal to 1, and then we'll say num x, let's just keep going with this, x high equal to, whoops, that's not what I meant to do. I'm just making this up. And then we can do num x low negative, like that. So we can pass in different variables here, and this numeric type, we can actually do a print num x, x. We can do plus num x high plus num x low, and we're just gonna run it. We don't know what we're gonna get, but this is kind of the basic of an algorithm we're actually building here. So we're actually, so anytime we pass in these numbers, this is the function we're creating, and we're printing it out. So when we add all of these variables together, we get this as the output. So that's pretty cool. So where I'm going is the int type has a range between, it can handle negative integers and positive integers. It's not a float, and floats can do the same. So if we copy this is going to make life a lot easier. We copy this, bring this down, and we do floats. Float type 1.0. We can do the same thing. We just say, we'll just put a floating point on this point like this. We can just, I'm making this up. And then we can put floating points on this. This will provide, and then what I'm going to do is change this to num FLT FLT. And just, you know what, while I'm thinking about it, let's make these ints. Num int, because we're making these more explanatory. So I'm kind of flying by the seat of my pants on this. So we're changing these to make this a little bit cleaner, so that once we get down into this FLT for floats, FLT and FLT, making it look more like a program. Okay, so we're going to run this, and then we'll see what we get. And then, so now you can see the difference. Okay, so this is what this is the difference between, we have more precision because we have added a floating point to this that allows us to do something beyond what the integer can handle. So the integer data type can only handle whole numbers. The float type, of course, just like it sounds, can handle float. Which means that I have a decimal point that I can work with, which to a large extent is a lot of what it is that, I mean, in scientific programming, you're dealing with a lot of decimal points. So floating points are going to be very much in your world as it comes to scientific programming. So just like before, these floats are, we can count on being these part of our normal everyday life in the scientific programming world. Now, we can also, floats actually have an ability to use E to indicate a power of 10. So this is a neat little trick. There's actually a math library within Python. We don't actually have to access it to get a power. We can actually just do a... we can actually just use, so for example, for a float, let's add in, I'm going to put it in right here, num float with E. So this denotes a little e indicates to a power of 10. So if I say 2E3, and then I'm going to do a print on that. Print here. And then let's see what we get. What's our last output going to be? It's going to be 2,000. So that's 2 to the power of so it's adding 3 zeros to it, right? So it's power of 10. But it's not an exponent. It's like it's raising it to a power of 10, right? So that add 3 zeros, and that's what's happened. Oops, there we go. That makes more sense. So that's something to kind of, it's a neat little feature of a float data type. We can actually do this on floating, not just this way, but we can also do like 0.4 E3 point. Actually, I think we can't do floating points on the E, but we'll try it just for kicks. I wonder what it'll do here. Yeah, so this has to be a whole number on the exponent because it kind of doesn't make sense for the power to be a power of, when you do a power of 10, it has to be the multiple of the 10 that you're raising it to. So in this case, yep, there you go. So you can do floating points on the left side. You can, like, so for example, we do this, it'll be right. And then if we go further, we can just go crazy with that. And then you're gonna, there you go. So that all works as intended. So that's where that works really well. I'm not going to go into too much more detail on that. I want to jump over to complex so you can see what that looks like, and then we'll do a short little run on conversions. I want to make sure that you have that available to you, and because it's something that is going to be used regularly in our in what it is that we do for scientific programming. So let's go ahead and get into just a quick run through of complex, and then we'll do complex numeric complex types. And then we won't do as many because it's just fine. Again, when we're using complex data types, it's something that will show up. And if you're looking to get an explanation of why they're used, complex data types, they're used to represent numbers that are both real, that have real and imaginary parts, and where representation of the real part and the imaginary part. So I'll explain that here in a minute. It kind of uh, it kind of makes life a little bit more difficult. I don't want to over explain it, but it comes in what's called an A plus BI form. That's why you see this. I'm going to put it as a string literal. That way, it's these come in A plus BI form. There we go. And then I'm going to put another string literal under it just to kind of keep it clean. Like this. Perfect. So this is where A represents a real number, and B represents the imaginary number. Okay, there we go. And that's why you saw kind of when we put complex in here earlier, this complex right here, I'm going to copy it down. So complex, and then we'll say num CLX. Let's do CLX. Complex. And then we'll put in something that is a little bit more, has a little bit more meat to it than what we've worked. So for example, in the A plus B, BI, BJ form, BI form, there you go. But the I is denoted with, I'm sorry, a J. Sometimes it's I, depends on, in Python, so in the mathematical notation, it's A plus BI, but the I is represented by a J when it's instantiated in Python. So just as it's kind of a quirk. So let's go ahead and get that started with something here that is a little bit more 3 plus 5J. And let's just run that. And then we're going to get an output of, oh, I didn't print it. Print num CLX. There we go. Run that. Okay, so you see I've got this in that form. And so I think the question then becomes Python complex data types. When do you use them? Again, whenever you have a need for to have something that is a little bit more comprehensive, it's going to show up in a few cases here in terms of what it is that we're doing from a scientific programming perspective. But a lot of times, one of the big advantages of a complex data type is that complex data types have over like other user-defined data types that we've been working with, which is a lot of what we've been doing here is that users can access and manipulate the individual components of a complex data type. And so you can mash into one variable multiple, as you see here, multiple different numerical strategies that you couldn't otherwise do with just a float or an integer. And so, for example, your built-in data types, they're strict, right? With a float, you can only pass floats. With integers, you can only pass integers. And so that's where complex data types come in, and complex numerics can be useful. I'm going to leave it at that because we can actually, if you want, you can actually chat GPT it there's going to be that would give you some good chat gpt would give you some good explanations of why you would use complex types. So that's an option. And also I want you to get familiar with using chat gpt to help with your coding, because that's just the way of the future. As we go through this, you'll find that chat gpt is going to be an invaluable resource for you to help explain programmatic constructs that professors aren't always the best at explaining. So anyway, I highly recommend it. If not, no worries. We're going to be just fine with what we're building out here. So with that said, let's move on to the last topic for this learning activity, which is casting. So these are conversions. So I'm going to keep it simple right now. And I don't want to get into all manner of big conversions, but I do want to do something simple, because this is definitely, I'm going to revisit this through examples. So let's do casting, simple casting example. And when we say casting, we're actually, what we're saying as computer scientists, what we're saying is that we're converting. That used to be the old term. I'm not exactly sure where casting, why we've switched from converting to casting, because it was years ago we used converting, and there were actually convert functions, but then over the years they've slowly been moving to casting functions. So so let's use a simple one. I'm going to create an integer, an int, that we'll call C, and then we're going to make that something like this. All right, and now I'm going to print int C, and we kind of went into this before, so we're going to be fine, right? We print int C, that's good. But now what if I want to concatenate? I want to concatenate this is a number, and then I want to add it to this. So I want to make something that's a little bit more explanatory, because for scientific programming, especially for prototype programming, and we're doing testing and debugging, we'll use these print functions to console all the time just to do a quick test on something. So we'll find out right here that this isn't going to work because it only concatenates string, not int to string. What that means is it's having trouble taking this integer and gluing it together to the string that is on the left-hand side here. So I'm going to actually put in something a little bit here, and I'm going to convert, or in this case, I'm going to cast the integer as a string. So I'm going to put a string function around it. And what that's going to do is it's going to convert the integer to a string and then allow me to concatenate to the string. So then I'll bypass this and I'll get an output. This is actually a nice little feature that you'll need to be familiar with, being able to go from here to there and back. So this is what we call casting from int to string. Now, let's say you're probably asking, well, can I go in the reverse? Yes, we can. We can go in the reverse. Right here, and we can cast from string to int. And in this case, let's say we started off with D. Let's say our number outputted, because this does happen sometimes. Let's say our number was outputted in such a way that it's kind of like a social security number. Because remember, a lot of times a social security number will come through and have a hyphen in it, which will make it like text, right? So I'm just going to do it like that. Yeah. 1 2 3 1 2 1 1 1. I don't know. That's made up social number. So hopefully no one has that number. But that social will come in as a string, And then what we want to do is that may come through. And as an example, I know it's gonna error out, but I can convert that to an int. An int d. There we go. Int d. And then we'll run this, and it's gonna actually error out on me. And the reason is because this has hyphens in it. But sometimes what happens is those are actually they're pulled through like this on the back end. So they could be stored as an integer, but they come in as a string. So what we do is to make this work, we'll actually convert the int to a string. And in this case, if I run this, what I'll do is I'll run that, and then this is still going to give us an error. And the reason is that I'm still having a problem with concatenating the initial string because I'm converting it to an int. Now, if I just print to explain this a little bit more, this is kind of an okay example, not the best, but if I do an int d, and then what I do is I do an int on the string, and let's say I make this SSN just for kicks. And I wanted to explain it this way to start because this is a common problem. SSN string, and then I'm going to pause on this for a second. And I'm going to make it this, this is an SSN number, like that. There we go. And then we'll run this. And that, I'm still going to get an error on int object is not callable. Int string is not callable. From string to int. Okay, so I've tried a couple different examples here, and apparently the casting from string to int isn't working in REPL. So we're going to go ahead and axe that. I've tried a couple different examples. The standard conversions in this case are something that we'll have to put a pin in because I'm not seeing how to do it. So for right now, we're going to just stick with the int to string conversion right here, but casting from string to ints or even floats. I've looked into the error that's popping up a little bit, and for some reason it's causing an issue. So I'm gonna axe this. I'm gonna try to circle back on this at another time to figure out why that string to int conversion isn't working. So I'm just gonna stick to the int to string conversion because that casting still works with this string function. So that's still okay, but we'll leave it at this for right now, and I'm gonna have to do some digging on the other issue as it relates to converting in the opposite direction, which is we can do that all day long, but for some reason REPL is having a tough time of it. Okay, so with that, I think I'm gonna wrap up this lesson for right now. I think that's all we need to cover for this learning activity. We've got plenty to run through, so just kind of a recap. We revisited last week, and then we went through our data types: text, numeric, sequence, mapping, set types, and booleans. Then we did a little bit deeper dive into numbers, which is the bulk of what I wanted us to learn, which is how to work with our numeric data types. And these are important in terms of what we need to use for scientific programming purposes. And then we did some simple casting from integer to string, because that is important sometimes for a debugging perspective. This is fairly common to do, but it's also common to go in the opposite direction. But apparently we ran into some issues here that I'm going to have to go dig into and figure out what's going on there. So nothing you have to worry about for right now, just something to be cognizant of that I'll be circling back on here pretty soon. And hopefully I'll get posted up a separate lab, a short lab that kind of explains the casting in a little bit more detail. I might have to open it up on another REPL, so that's okay. But just be on the lookout for that. It'll be a short one. Hopefully, I can get this resolved with REPL on the issue that we're bumping into here with the casting. With that, that's all I got for this learning activity, and I will see you in the next learning activity.